Hey everyone, it's Mr. Spiels. I'm going to be helping you out today with related rates problems that have one too many variables. You set up your equation and you have too many unknowns. In a lot of these problems, or in all of these problems, you're going to be able to set up a proportion, or what we're going to call similar triangles, to basically reduce your number of variables so that you don't have too many unknowns. Okay, so let's work with this first one. A lot of these types of problems where you have similar triangles or too many unknowns is going to be a conical tank problem. That's going to show up a lot over the next few practice problems here. So a conical tank with vertex down is 10 feet across the top and 12 feet deep. Okay, let's just draw that. So a conical tank with vertex down. Okay, that means my cone is facing down, okay, like this. Okay, water's flowing into the tank, so it looks like we're pouring water into this tank at a rate of 10 cubic feet per minute. All right, so cubic feet per minute, and we're flowing into the tank, so we're filling it up. This is a volume equation. So we're, again, cubic feet per minute is volume. So volume of a cube, or not cube, volume of a cone, I should say, is 1/3 pi r squared h. Okay, and let's just finish the sentence here. Find the rate of change of the depth of the water when the water, or at the instant the water, is 8 feet deep. Okay, so right now we've got a volume we're dealing with, a radius we're dealing with, a height we're dealing with. Let's start to fill in a little bit of this diagram here. Let's go back to that first sentence. It's 10 feet across the top. Well, if it's 10 feet across the top, that means my radius, right? I want to change this to radius because that's what's going to be in our equation. My radius is going to be 5 feet across the top. Now it also says it's 12 feet deep. So from the top all the way to the bottom here is going to be 12 feet deep. Okay. Water's flowing into the tank at a rate of 10 cubic feet per minute. So let's think of that as our dV dt. Okay, we're flowing into the tank, so that's going to be 10 cubic feet per minute. And it's going to be positive because we're filling up the tank. It's not leaking out of the tank. If it was leaking out of the tank, it would be negative. Find the rate of change of depth of water when the water is 8 feet deep. Okay, so the water's 8 feet deep. Now let's just call, again, we're calling this depth our height. So at the instant that our height is 8 feet deep. Okay. What you'll notice here, now when I draw, let me just move this 12 a little bit out of the way here. Call that 12. When I draw this at 8 feet, move the 12 up here. 8 feet, okay, let's just picture this water. Okay, let's say it's like right here. Okay, this is my 8 feet right here. So now let's look at our equation. We've got volume, so dV dt. Okay, we've got a height that we can plug in. Okay, that's going to be our 8 from down here. But when we're at a height of 8 feet, so again, at this point on the water, let's say again, here's my water, it's 8 feet deep. We don't know what this radius is. Okay, and I'm going to try to use different colors here to set this up. Okay, so in my red, I've got one little triangle going on here. I know my height, or my depth, is 8 feet. That's what I'm looking for. Okay, I have another triangle here, the outside. It's my purple. That goes all the way to the bottom here. Okay, so we're going to use those similar triangles to write a proportion so that we can substitute. Right now we don't have any idea what this r is, okay? And we're going to be stuck because we won't have anything to fill in for that part of the equation, okay? So if I set up my proportion, I can say that 5, okay, which was the initial radius up here, is to the new radius, and that's equal to What was our original height? 12 over our new height, okay? I know our new height is 8, but what I'm doing here is I want to write radius, my r, in terms of height, okay? So if I cross multiply here, okay, 12 times r is 12r, 5 times h is 5h. So now I'm going to write r in terms of h. So this is going to be 5/12 h, or 5h over 12. Okay? The reason I did that is because now I can substitute this r into my volume equation. Okay? So I'm going to rewrite my volume equation as v equals 1/3 pi, and now instead of r squared, I'm going to write 5/12 h squared times h. Okay? Again, the reason I did this is because I know what this h is. It told me that in the problem, gave me 8 feet. What it didn't give me was this new radius. So I couldn't have used that. If I were to leave this equation the way it is, I'd have nothing to plug into there. So I had to write r in terms of h using similar triangles. Okay? I'm not taking the derivative yet. I'm just simplifying this equation. So this is going to be 1/3 pi. Now the 2 goes to everything here. So this is going to be 25 over 144 h squared times h. Okay. Now, I've got a fraction here, 25 over 144. I've got another fraction here, 1/3, so I can multiply those, combine those. What this is going to come out to is 25 pi over 432 h to the third, right? Because consider this 1, 2, and 1 gives me 3. Okay. Again, hopefully you're starting to see the reason why I set up these similar triangles now, because I took my r, substituted in. Now I'm down to just one variable on the right side of the equation, the h. So that's way better than at the start when I had 2 variables. Okay. Now I'm ready to take the derivative. All of this up here was just simplifying my volume equation. Now I can take the derivative. So let's say dv dt is equal to, okay, now we're going to take the derivative here. If I multiply 3 times 25, that's going to give me 75 pi over 432 h squared. Now I took the derivative, so I have to write dh dt after it. Okay? And that's what we're looking for. Find the rate of change of depth of the water. The rate of change of depth of water. That is dH dt. Okay, change in depth of water with respect to time. Okay, so that gives us what we're looking for. At this point, we can pretty much plug everything in. Okay, so one thing I just want to make sure of here is I want to plug in my dH, or let's say dV dt is equal to, I'm going to plug in my h here. So this is going to be 75 pi over 432. Now h squared is going to be 8 squared is 64 dH dt. Okay, again, this was just the 8 squared that we had at the start here. That was one of our givens. Okay, when I solve for dH dt, let's see, what was dV dt? dV dt was 10 equals, now over here, if I multiply 64 and 75, it's going to be 4,800 over 432 pi times dH dt. Okay, and when I divide both sides, when I divide out to get dH dt by itself, I'm going to do a little bit of rounding here to the nearest thousandth. I'm going to get 0.286 cubic feet per minute is equal to dH dt. Now, there's going to be You could either write it like this. You could also leave it as a fraction in terms of pi. Either way, that would be a more exact answer. This obviously would just give you a decimal. Okay?